Chemistry is the study of matter, the 118 elements that make up everything we see. It is also the study of change, as atoms form bonds to create compounds, and compounds react with other compounds to make new substances from old. It is the bridge between the other sciences, holding everything together. You are about to enter a world so small that gravity no longer matters, and we must turn to other forces to explain its existence. This is chemistry.
Part 2. The Elements and the Periodic Table. In Part 1, we learned that an atom is the smallest possible division that still retains the properties of its elements. So now we must ask, what is an element? I also mentioned in Part 1 that not all atoms are created equal, so we will now address how they are different. Recall that the nucleus contains protons and neutrons with electrons in orbit around it. The simplest atom, then, has one proton with one electron orbiting it. Since there is only one proton, neutrons are not needed to hold the nucleus together. All atoms that look like this are known as hydrogen, which is the simplest and most abundant element in the universe. It can have neutrons, but usually does not. Add another proton to the nucleus and suddenly you need neutrons to hold it together. The element formed when a nucleus has two protons is helium. If helium is stable, it has either one or two neutrons. The rule is that the number of protons determines the element, not the number of neutrons, as neutrons do not change an element's chemical properties. When an element can have a varying number of neutrons, it is said that it has different isotopes. Elements can have anywhere from 1 to 118 protons. The heaviest naturally occurring element, uranium, has 92. As far as familiar elements, carbon has 6 protons, oxygen has 8, aluminum has 13, iron has 26, silver has 47, and lead has 82. Elements with 83 or more protons are all radioactive, which means they are unstable and turn into other elements. This will be covered in depth in a later video. The number of protons in an element is called that element's atomic number. Elements are organized on the periodic table. To start decoding this mysterious chart, we have to understand electrons. For simplicity, we will focus on the first 3 rows to start in order to grasp the basic rules. Electrons organize themselves in different shells, and each shell has a different amount of energy. The first shell can hold 2 electrons, and the higher shells hold 8 in their outermost shell. Each row represents a new outer shell, and each column represents the number of electrons in that outer shell. All the elements in the first column have 1 electron in the outermost shell, the elements of the second column have 2, and this continues all the way to the last column, where all elements in that column have 8 electrons, with helium being the one exception. Why is this? Since the first shell can only hold 2 electrons, helium has a full outer shell, just like the other elements in that column. This makes it have similar properties to the other elements in that column. In the next part, we will cover more specifics on how electrons are arranged in an atom and how this leads to trends in the periodic table. Thank you for watching, and until next time.